Hello scholars, welcome. Mr. Hinkle here, continuing our discussion looking at specific types of metamorphic rocks, rocks that have changed their form through the processes of being subject to heat and pressure in a variety of tectonic settings. So let's get into it. Discuss common types of metamorphic rocks. So non-foliated metamorphic rocks are rocks that have minerals that have recrystallized during metamorphism, but they do not have a planar fabric, which is left over from the last lecture. See, foliated metamorphic rocks. Rocks that have a planar fabric are called foliated metamorphic rocks, and rocks that do not are called non-foliated. So our objective here is to go over our common non-foliated metamorphic rocks. This pen, let's get rid of it. Okay, so we'll start with hornfels. Hornfels is going to be a fine grain. This is a very difficult rock because it looks like basalt, it looks like shale, it looks like many other rocks. But if you carve it open underneath, you take a thin slice and look at it underneath a petrographic microscope, you will be able to see the metamorphic change. It's hard to identify the protolith, it's hard to identify the actual rock, but this is a rock that occurs in low pressures with very high temperatures, giving you a very specific mineral assemblage. So, if we were to make a short list, hornfels. Amphibolite, another non-foliated metamorphic rock that has a dark color. Primarily, the mineral hornblende has recrystallized, but there's also some plagioclase inside of this mineral. Another dark, non-foliated metamorphic rock, amphibolite. Something a little bit more common that we see, quartzite. We've got a couple different colors of it, but quartzite comes from the protolith quartz sandstone, which is sand at the beach that becomes a classic sedimentary rock, very common on Earth, subject to heat and pressure. Those quartz sand grains fuse together to give you a dull, massive, very, very hard type of rock, quartzite. Quartzite, I'm just going to put this one up here now, and marble are challenging to distinguish one from another. Got a nice big chunk of marble here. But marble is from the protolith limestone, and you have a recrystallization of the ions that create interlocking grains. Bring this a little bit closer. And there just seems to be a more magnificent, brilliant look to the marble than there is to the quartzite. And being from limestone, it's calcite or dolomite crystals that have precipitated, which means it will react with acid, which is a nice test to see if you actually have marble or you do not. Serpentinite is the metamorphism of ultramafic rocks. Most often, the mantle material, peridotite. Under the right conditions, that mantle material can change its form, creating a green, scaly, wavy, serpent-like texture that we call the rock type serpentinite. And last but not least, we have anthracite coal. So coal undergoes this process where lush swamps fill up with organic material. That organic material accumulates, transforms into peat, into lignite, into bituminous coal, a sedimentary rock. Keep burying it, get a little bit hotter, more pressure. That bituminous coal transforms into the metamorphic rock anthracite coal. And anthracite coal has a very shiny texture to it. It looks more chemically altered, where our bituminous coal has more of an earthy, dull appearance. The anthracite coal is going to pop, it's going to shine, it's going to look like it's undergone those metamorphic changes. And something that, I know this is a video, but it's something that you gain through experience, getting your hands on, seeing lots of samples in order to really understand how to identify these rocks. But we are identifying metamorphic rocks first by foliated or non-foliated, and then by looking at their temperature? No, their textures and their composition. So non-foliated rocks were in environments with directed pressure minerals, without directed pressure that allowed for recrystallization to create equant minerals. They exhibit preferred alignment, no preferred alignment or foliations, and give us uniform physical properties, leading to some common non-foliated metamorphic rocks: hornfels, amphibolite, quartzite marble, serpentinite, and anthracite coal. Thank you so much, and I'll see you again.